This is lesson 1-7, represent functions as graphs. You should be on page 43. You can use a graph to represent a function. We've already looked at this on the last video. I had you fill out a worksheet where you had a verbal rule, you had to write an equation, you had to fill out a table, list the domain and range, and then on the far right there was a column where you had to graph that table. This lesson is exactly about that. We can use a graph to represent a function. It's important to understand that when you see, remember I've talked about languages in class, when you see a table, this is telling you if you input 1, the output's 2, if you input 2, the output's 3, and if you input 4, the output's 5. In ordered pairs, that is telling me the exact same thing as my table. Input 1, output 2. If you input 2, output 3, and if you input 4, output 5. And the graph is telling me the exact same thing again. You can look. If I go 1 right, 2 up, that's my point. That means if you input 1, the output's a 2. And you can see the point 2, 3. If you input 2, you output a 3. And if you input 4, you output a 5. This is like 3 different languages that are telling me the exact same thing. And we discussed that in class the other day. So in the homework today, they're going to ask you to graph a function. So in this particular example, when you read the directions, it says graph the function y equals 1/2 x with a domain of 0, 1, 2, 0, 2, 4, 6, 8. So remember, I have this mental image. I'm going to take these domain values, I'm going to input them into my computer, and my computer is going to create outputs. So I'm going to input 0, 2, 4, 6, 8. And I'm going to take each of those inputs, the computer's going to half each one and create an output, which would be 0, 1, 2, 3, 4. You can see that in the tables, or in the table that they wrote here in the book. There's my inputs. Maybe I'll highlight them in pink. There are the inputs, just like I have here. And here are my outputs in the table, just like I have here. Now that table means the following. I'm going to click it on the screen right here. This table is the same as these 5 ordered pairs. And I'm going to graph those ordered pairs. And you can see it's creating a straight line of points. If you are not getting a straight line of points, something's wrong either with your calculations or you've made a graphing error. You'll have some story problems that they will ask you to graph. In this particular story problem, the table shows the average score S on a mathematics section of the SAT in the United States from 1997 to 2003 as a function of time in years T since 1997. In the table, 0 corresponds to the year 1997. So when they say that, they're saying year 0 would be the equivalent of 1997, and year 1 would be 1998, and year 2 would be 1999, and so on. Graph the function. Well, here are my inputs. Let me highlight those in green. My inputs are here, and my outputs would be here. So to graph this, there's something we got to be careful on with these word problems. Right here, it's super important. I put a little red star next to it. You have to choose a scale that's appropriate. The scale should allow you to plot all the points on the graph in a reasonable size. So in order to do that, the first thing we should do is examine our inputs and our outputs. So if you look carefully here, my inputs I've highlighted in pink. They go from 0 to 6. Well, let me see. Would it be reasonable? Now remember, the inputs are X. Would it be reasonable for my graph then to start at 0 and go up 1 unit at a time if I only have to graph from 0 to 6. And if I look, 0, 1, 2, 3, 4, 5, 6, that would take up an appropriate amount of graph paper. Sure, that would work fine. Okay? On the other hand, when I look at the average scores, and I've highlighted those outputs in green, remember the outputs are the Y's, I have to get all the way up into the 500s. Think carefully if I pick a scale that goes 0, 1, 2, 3, 4, 5, 6, and so on, 1 unit at a time. Think about how much graph paper I'm going to need to get this all the way up to the 500s. I'm going to have sheets of graph paper taped together to make that happen. That's not going to be a good scale. So what they did, and you can see here, when you see this little symbol, a little broken interval symbol, that means I am skipping from 0. It looks to me like they skipped this graph from 0 all the way up to 508. This must be 508 because here's 510, which is 2 units up, which means this is 512, followed by 514, 516. Are you seeing that the interval that they chose here is 2, intervals 2, and they started the graph, once they skipped from 0, they started it at 508. So we're going up by 2's from 508 on up, and it allows me to plot these points. And this looks nice, and it's in a reasonable size graph. It's not, I don't have 10 sheets of paper taped together to make it work. What if? And I just talked about this. What if I had chosen a scale that starts at 0 and it goes up 1 unit at a time to 520? Describe the appearance of the graph. Well, we just talked about it. It would take pages of graph paper to go 1 unit at a time up to get to 520. And that would kind of break the rule of having a reasonable size graph. And as a teacher, if it's not reasonably sized, and I don't want to use the word attractive, but if it doesn't look reasonable and convenient to read, I'd have to mark it down. A graph should be convenient to read, reasonable size, and display your points. Write a rule for a graph. So write a rule for the function represented by the graph. And maybe I should just stop real quick and just mention I'm covering this now because these kind of questions will be in the assignment today. Write a rule for the function represented by the graph. Identify the domain and range. So you notice they gave you a graph, they want you to write a rule. So before you write a rule, here would be the first step. Make a table for these points. Let me read these points real quick with you together. It looks like here we have 1 right, 2 up, which is the point 1, 2. Does it make sense why they took that point, and in the table, there's 1, 2. And then the next point is 2, 3. So on the table, can you see input 2, output 3 right here where I'm pointing? And then the next point is 3, 4. 3 right, 4 up. So can you see input 3, output 4? There's my table, input 3, output 4. And then, of course, we had 4, 5, and there's input 4, output 5. I'm pointing at it here. And then 5, 6, 5 right, 6 up, which would be input 5, output 6. So make a table, and here's why you want to make a table. It's kind of easy to see the pattern if you can look at the table. It's pretty obvious we're adding 1 every time. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and so on. The pattern is add 1. So the output here equals the input plus 1. That's the pattern, which means my rule is y equals x plus 1. Remember, outputs are y, inputs are x, and I'm adding 1 each time. There's my rule. Don't forget, there was a second part to the problem. Identify the domain and range. So when I do that, my domain is here, And you can see they didn't just circle it, they wrote it down. The domain of the function is 1, 2, 3, 4, and 5. My range is 2, 3, 4, 5, 6. They didn't just circle it, they wrote it out. The range is 2, 3, 4, 5, 6. One last thing here, and I don't need to really discuss this with you. You should have seen this before. What I circled here should not look foreign to you right now. This is the worksheet that I covered in the last video, that very thing. And that's the end of the video, and we'll finish that worksheet, and you've covered what we need then for this lesson.